All right, we're going to learn about econfiguration today, or electron configuration, or econfig. And first what we have to do is we have to color in our areas. So this first two columns here, the first two families, 1 and 2, and this coincidentally includes helium over here, because helium can sometimes pretend that he's right here. Okay? And this is our S block. That's a lowercase s. And then we jump over to our P block, which is over here on this side and includes everything else over here. And again, lowercase p. Then we get to our D block. Okay, they're at the dip, if you want to remember that, or where the periodic table kind of drops down. That's the D block at the dip. And then the F block is down here at the bottom. Now the F block actually exists right here. Our periodic table actually would be more like if we wanted to be actually realistic. Okay, with our S area over here, and then our P, and then our F. And then our D, and finally our P. So it kind of looks a little bit weird here, but the periodic table will be too stretched out that way. That's why we do have it listed with the F block stuck at the bottom, and then this is just the F divide. Okay, we're not going to do electron configuration for our F block. We're going to save that for IB or AP or college. And the main thing you have to remember is to go slow. Go slow with each one when we do the electron configuration. So I'm going to start here in my first block. That's hydrogen. Okay, hydrogen is in the row 1. Sorry, let me put the rows here. These are called rows or periods. And it's okay that they repeat down here because of the F block, because remember it's stuck up in there. So it is in row 1. It's colored S, and it only has 1 electron, and that is hydrogen. And then our next guy that we're going to do is helium. How many electrons does he have? He has 2. Helium is in the first row. Both of his are S, and there's 2 of them in the S. And that actually caps out the 1s. There's only a maximum of 1s2, because we're now out of space. Okay, so now we go on to our next guy. So we're at lithium now, and we start over again. Okay, lithium doesn't just have 3 electrons when he's an element, or 1 electron when he's an element. He has 3 electrons when he's an element. We can't just start with where he's last at. We have to go back to the beginning. So he has an electron in the 1s1 and an electron in the 1s2 spot. So we just write that 1s2. And then his third electron is a 2, an S, and a 1. And now we keep going on. We have beryllium. Beryllium is right here. In the 1s2, row 1, they're both S's, and there's 2 total. And then in row 2, 2s2. Now we're going to go on. Our next guy is boron. He's over here. He has 2 electrons in the first row, so he's a 1s2 because they're both red. He has 2 electrons in the second row and then in the S, so 2s2. And he has 1 electron that's in the second row, and a P and a 1. So this next guy, that's carbon. 1s1, 1s2, so 1s2, and then 2s2, 2p2. The next guy is going to have the same exact start. 1s2, 2s2, 2p3. So 1s2, 2s2, 2p3 is nitrogen. Then we come over here to oxygen. Guess what he's going to have? 1s2, because that's the first row. 2s2, that's both the reds in the second. 2p, 1, 2, 3, 4. So 2p4. Our next guy over here is fluorine. 1s2, 2s2, 2p5. And then we're going to max out here with our noble gases. So remember, they don't like to react, so they are all full. They like their row to be completely full. They have a full crown around their head. And so to max out this row, 2s2, 2p6. So if I do the electron configuration for neon, he is 1s2, 2s2, 2p6. So it's added up of both of those guys. So then I have sodium. 1s2, 2s2, 2p6, 3s1. Magnesium. 1s2, 2s2, 2p6, 3s2. And he is done. Aluminum. 1s2, 2s2, 2p6, 3s2, 3p1. So it's going to repeat every time. So if you know what the maximum of the line is, you already have those first parts. So that's kind of your cheat sheet over here on this maximum. So now I have silicon. 1s2, 2s2, 2p6, 3s2, 3p2. Now I have phosphorus. Again, 1s2, 2s2, 2p6, 3s2, 3p3. Now we have sulfur. 1s2, 2s2, 2p6, 3s2, 3p4. Chlorine. 1s2, 2s2, 2p6, 3s2, 3p5. And now we're coming up to our max one again. 1s2, 2s2, 2p6, 3s2, 3p6. So I'm hoping this is starting to make sense. You might have to watch the video a couple more times. I'm just going to do 2 more, but I'm going to do them on a clean sheet of paper to see how you go. Okay. So potassium, 1s2, 2s2, 2p6, 3s2, 3p6, 4, so it's on the 4th row. It's in the S, and it's the first one in the S, 4s1. And then we're going to end up with calcium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So if you notice, the number that's in front, that's the row or period. The letter is always lowercase. Okay, and it's an S, a P, a D, or an F, depending on what color it is. And then this superscript, it has to be superscript. So it has to be raised up. Okay? And it has a maximum of 2 for S's. So there is no 1s3. It maxes out at 2. S maxes out at 2. What does P max out at? Looking at here, I can see that the maximum electrons for P are 6. So I'm getting a lot of information in here. What other information can I have? If I add up all the electrons, so all the superscripts, then it tells me how many electrons are in that particular element. So potassium has 2, 4, 10, 12, 18, 19. 19 electrons. Calcium, when we add it up, 2, 4, 10, 12, 18, 20 electrons. So you know how many electrons they have from the electron configuration, and you can actually specifically talk about a particular electron to know where he's placed based on the periodic table. And then we can get into more detail about what that means later. But right now, you now know how to write the electron configuration for the first 20 elements.